So you want to find out whether the products formed from electrolysis of dilute sodium chloride solution are going to be different from those of concentrated sodium chloride solution. Well, you are in the right place. Not only will you be able to determine that by the end of this lesson, I will also share with you 2 tricks that will help you determine the products of any electrolysis. So let's get into it. Now in this, we are going to have electrolysis of dilute sodium chloride solution. So sodium chloride solution is going to contain the following ions. We are going to have sodium ions and chloride ions. These of course are going to be from the sodium chloride. We are also going to have hydrogen ions and hydroxide ions from the water. When an electric current is passed through the solution, chloride and hydroxide ions will move towards the anode, while sodium and hydrogen ions will move towards the cathode. Now, in case you're wondering why this is so, I've got 2 words for you: opposites attract. The anode, being the positive electrode, will attract the negatively charged ions, while the cathode, being a negative electrode, will attract the positively charged ions. Now, on to our first trick. How would you remember which electrode is positive or not? Panic. So positive, anode. Negative is cathode. Now once we've established which ions are going to be at the anode and cathode, our next step is determining which ions are going to be discharged. You know which ions are going to gain or lose electrons. One thing that you need to remember is that electrolysis is a redox reaction. So you're going to have reduction and oxidation taking place at the same time. Reduction involves gaining of electrons, oxidation the loss of electrons. So the electrons that are lost at the anode are the ones that will be gained at the cathode. Now, how will you know which process takes place at the cathode or anode? Now, this is where I share with you my second trick, anox. At the anode is where oxidation takes place, red cut. Reduction is at the cathode. At the anode, which ions are going to lose electrons? It's going to be the hydroxide ions. This is because hydroxide ions have a greater tendency to lose electrons compared to the chloride ions. And that is our half equation. Moving on to the cathode. At the cathode, we have sodium and hydrogen ions, but it's the hydrogen ions that are going to gain electrons. And the reason for this is because hydrogen ions have a greater tendency to gain electrons compared to sodium ions. And there we have it. Just a point of note, the number of electrons that are lost at the anode are the ones that are gained at the cathode, so they should always be balanced. And this is electrolysis of dilute sodium chloride, where we're going to have evolution of oxygen gas at the anode and evolution of hydrogen gas at the cathode. So essentially this is electrolysis of water, since both oxygen and hydrogen are constituents of water. Moving on to our second one, electrolysis of concentrated sodium chloride solution, also known as brine. So we're going to have the same types of ions: sodium ions, chloride ions, hydrogen ions, and hydroxide ions. The only difference is in the concentration. So we're going to have a higher concentration of sodium and chloride ions. When an electric current is passed through the brine, chloride and hydroxide ions will move towards the anode. But in this case, it's the chloride ions that are going to be discharged because they are at a higher concentration. So the chloride ions will lose electrons to form chlorine gas. So chlorine gas is going to be released. At the cathode, we are going to have sodium ions and hydrogen ions. But in this case, you're not going to have sodium ions being discharged even though they are at a higher concentration. And the reason for this is because hydrogen ions have a greater tendency to gain electrons than sodium ions. So the hydrogen ions are going to gain electrons and form hydrogen gas. Now I have a question for you. Why would the solution become alkaline after some time? Hit the answer in the comment section and I'll see you next time.